in TypeScript, Rawkode bringing shivers. Jack Kleeman's here to guide, workflow slide and slide. Restate.dev in hand, automation plan so grand. Learning to build workflows, watch the magic grow. Code it all as we go. Tech love we bestow. Academy so bright, coding through the night. Functions form the light, tech dreams taking flight. Academy so bright, coding through the night. Functions form the light, tech dreams taking flight. Pipelines running strong, coding all night long. With these tools we belong in this techy song. Learning to build workflows, watch the magic grow. Code it all as we go. Tech love we bestow.
Hello and welcome back to the Rawkode Academy. I am your host, Rawkode, although to my wife and kids, David Flanagan, and to my neighbours in this office block, the guy that has been playing Linkin Park far too loud for the last 48 hours. So welcome back. Today we're carrying on with a Rawkode Live series in which we take a look at awesome projects in the cloud native and wider space that help make building distributed systems easier. And today we are taking a look at Restate, which is found at Restate.dev, and I am joined by one of the maintainers.
Hi,
Jack Kleeman.
how's it going?
How's it going?
Not too bad, not too bad. How are you?
Yeah, just enjoying the day. It's a nice, easy start to the week, especially when I get to sit in front of a camera and play with some awesome technology. But
Nice.
before we get into that, why don't you tell us a little bit about you?
Sure, yeah. So I'm Jack. I'm a senior engineer at Restate. I focus mostly on the cloud platform and the Go SDK and a little bit of the TypeScript SDK, which I think we'll be getting into today. I spent pretty much my entire career in cloud native, starting off at Monzo, where I was doing like security for Kubernetes, basically. And that was pretty fun because we had literally 1,500 services at the time, and I think now they're like 3,000. I actually went really viral on Twitter like 4 years ago for tweeting an image of all of our services talking to each other, and all these people were retweeting it, being like, "This is such a bad design," and transient failures are going to destroy you, all this kinds of stuff, and like, "Oh, the retry failure amplification." And so that's kind of what started to get me really passionate about like making distributed systems work, removing these problems, abstracting them away. After that, I went to Apple. I worked as SRE. I saw what it's like to like really maintain extremely large, complicated systems, like highly multi-tenant teams that maybe don't do always the right thing. And that was really fun as well. And yeah, that led me to Restate, where I guess our mission is to try and make it easier to build complex interrelated systems. I mean, even when you have two processes running on the same machine, you have a system that can fail in their communication. Then you have two different machines, it gets even worse, and two different data centers in two different countries. So many companies are struggling with just splitting one process into two. And I guess Restate is trying to make those things a lot better than they were before. So yeah, that's about me.
So is the TLDR from that we should just build monolithic applications and deploy them on a single box?
I think if that box is a mainframe, then yes, I think absolutely. I mean, I guess for me, like the pitch I always had at Monzo was microservices weren't solving a tech problem there. They were solving like an organizational problem. Like they made it so much easier to have teams that don't have to like have shared design reviews or have like shared, complexity or lots of concern about shared libraries and things like that. Instead, we just had these really simple RPC contracts, and teams could just develop really quickly independently. And that's what got me hooked on this. And yeah, to make that work, you need this like incredible platform team, and they were so good, the team at Monzo. And yeah, that's what got me passionate about. Like, if you can make the platform good enough, then you can get it to the point that it's almost as technically good as being on a mainframe, like massive IBM machine. But you get these massive developer experience advantages if you can allow teams to operate independently and so on. So yeah, that's my mission really, is to make this better.
Nice. I love that we have a very similar mission. I mean, I think we've both been in this cloud native space for a while, and I always tell people that microservices are really simple. That's the whole point of them, right? You're supposed to be able to fit them in your head and be able to rewrite them rather than change them. But that complexity doesn't disappear. It's been pushed down to platform and infrastructure layers where they have to build a lot of tooling and automation and remediation. Everything has to happen there. But it's in the let's make developers' lives easier. Let's have them focus on what they enjoy doing. And I think, there's a lot of trade-offs in every approach to building software. But I think in 2024, when we have things like Restate and other tools, as we'll see today, these harder challenges are getting easier too, which is wonderful. And I'm excited to share that with people.
Absolutely. Yeah. So the methodology that it seems to exist like in the wild, and what I've always experienced, is like you have some kind of mismatch of like KV stores, queues, RPC frameworks, retries, and the end result can be like really reliable and really good, but that's quite a lot of mental load for engineers, and they have to worry about things like idempotency and just lots of new concepts. So my hope is that we can start to unify some of these tools together, and just bring the code back to being 95% business logic. You can never pretend that the distributed system's not there, or like the network isn't there. That's just fantasy. But can we get much more of the proportion of the code to be business logic and not instantiate Kafka client, or is this a retry, or check the token against a DB to see if we failed, or these sorts of things occupy a lot of time at microservice businesses, and that's what I'd like to sort out.
Nice. Now, I don't want to spoil too much for the people that are watching, but I will clarify that I am using Restate right now in the Rawkode Academy infrastructure. And the first thing we deployed turned out to be the easiest bit of code I've ever written in my life, but it's actually quite complicated what's happening underneath the hood. And it's when people register for the Rawkode Academy website, we obviously create a user account for them, but we don't activate their account until they've verified their email address. And we were able to hook that up in one line of like Restate workable magic that just kind of sits there forever and says, I'm going to wait until you've proven to me that this account is activated. It was astounding to see. And we're going to share.
And this is all running serverless as well, right? So when we say wait, what do we really mean? I guess we'll get into that, but that's the exciting thing.
Awesome. All right. So I went down a tangent already. Let's back up a bit for people that are watching and they're still like, wait, what the fuck is a Restate? Like, maybe we can give them the pitch. What does Restate deliver for the average developer that wants to build fault-tolerant distributed systems?
Yeah, so I guess I'll start with the sort of the primitive that we offer, and then maybe I can go into like how it fits inside the infrastructure. So what we offer is suspendable functions, and what I mean by that is code that can save its progress kind of at any point, and resume later. So if you've come from a Go background, this might sound a little bit like a distributed coroutine. If you come from a JavaScript background, maybe you might think of this as being like a distributed async runtime or like async event loop. And yeah, this is a little bit of a new concept, but the idea is that when your program fails, for example, like the machine dies or crashes, we can resume from that point onwards. But it's a lot more interesting than just failure, because there's also this idea of like, sometimes code, it's a lot more helpful if you could just think of it as waiting for something, like for a long time, like even for a week. And you can't really write code that way, because you're guaranteed to hit some kind of infrastructure failure if if you wait for long enough. Or if you're running serverless, you're being billed by the second. So the fact that the code can sort of invisibly or somewhat invisibly save its progress, shut down, and then resume at that point at a later date when the thing it's waiting for is done, that's really useful primitive. It sounds like that's the one that you were using, which I imagine we'll go into. But so that's what we're trying to offer. The way that it works is by writing down more. So applications right now are not particularly stateful, or we don't see them as being super stateful other than what they save in the database. And saving something in the database is something that engineers have to like deliberately do. And kind of the more you write down or the more you save, the better. And when we write to Kafka, we are also writing something down. I mean, it may not feel that way, but Kafka is like a durable log and can actually store messages for a really long time, right? So we are making it much easier to write things down. For example, when you make an RPC between two services, that's going to be persisted. When you do something like create an idempotency token, that's going to be persisted. And lots of other things as well. And we try and do this without really changing the way you write code at all. The end result is that the program can be stopped and then resumed and all the previous values filled in and then continue from where it was. And that's what allows it to do things like sleep for a week or wait for a user input for a year. I mean, these sorts of suspendable properties are really helpful, but it's also really helpful for failure of any kind. I mean, obviously some types of failure, like user failures, or like the infrastructure just isn't running, these things are difficult to deal with, but things like the network failing or the user closing the browser tab or these sorts of things, by writing more down, we can allow complex workflows to resume from the point at which they failed. And this makes it a lot easier to reason about idempotency, because if you think about like 10 steps and you get to the 9th, if we then start from the beginning, making that whole thing idempotent is quite tricky. But with Restate, you kind of only have to worry about that last step. Like maybe it could be run again if it like failed before we managed to save the result, but we know that the previous steps that were saved, they will never run again. And that makes things a lot easier for engineers. So these are the sorts of primitives.
Can I challenge one of the things you said there?
Yeah.
You said that it doesn't change the way that we write code. And I've actually found, no, I'm going to sit here and say you're wrong, but I kind of am, right? I've actually found this made my code a lot simpler because we have this linear flow of what things are supposed to do. And I found myself, I've not had to reach for like state machines and complex modeling of these situations anymore, because we are able to map things as a linear progression of events. And I've found that things are just a lot easier. I'm not sitting there going, oh, I'm in this state of waiting for activation. And I'm not having to worry about idempotency of the first 9 steps. You're right, like that is a challenge. But that suspendable linear progression does change the way that we write code, but for the better, drastically for the better.
So I think what I really mean is you don't have to write the code much differently to if it was just running on your laptop. And for example, waiting for input, it was just the process was just waiting. Or sleeping for a month, it was just sleeping and you kept it on your desk or whatever, which is a perfectly fine way to write software. But the moment that you go serverless or really into any like Kubernetes environment, all of these things become somewhat impossible. So that's the world we want, is like super imperative, like coding on a Commodore 64. The thing that the code says it's doing is what it's doing. The right way to do it without Restate, as you said, is like actors and queues and complex systems, and they do change the way you write code, and there's absolutely nothing wrong with them. They're amazing tools, but our hope is that we can distill down their properties with a different API. And maybe that brings me on to the position of the infrastructure, because essentially we do look a little bit like a message queue. We look a little bit like a Kafka. We're a stateful message queue. It's a streaming system, and we have similar properties to if you split your application up into lots of event handlers that, you know, every single step is its own event handler, and you would just kind of hop between each step with the state that needs to be sent between each step. And that, by the way, is exactly how we built complex distributed systems at Monzo, was we would just put everything into handlers. If it needs to be reliable, it's an event handler. And that is really a lot harder. So yeah, that's what I'm excited about, is maybe you can just write, do this thing, then do this thing, then wait for this thing for a week, then sleep, whatever you want to do. And it will just look like the simplest code, but has different properties.
All right. I'm really disappointed that we're 15 minutes in and no one has said rushed yet. So I just thought I'd get that out of the way. I try not to go that long without
That's
saying
true.
it. But.
That's true. But we get criticized for advertising that we're for Rust, and part of the reason for that was that until about this week we didn't have a Rust SDK. So now we do. We can say that we're
There's
for
a Rust
Rust
SDK.
people.
What?
There is as of like right now. Yeah.
Okay, that just changed the entire session.
Okay, well, maybe we should talk about that as well. But we have been criticized in the past because it's like, yeah, you're building with Rust, but you're not building for Rust people. Okay, well, now we are. But it's true that our first SDKs were Java and TypeScript. Now we also have Go, Python, and Rust. So things are expanding fast on that front.
I think there's obviously a lot of frustration in the developer community where people are rewriting things in Rust that maybe don't need to be rewritten in Rust. But I think something like Restate should be written in Rust, but it doesn't necessarily mean the end consumer is going to be writing all their stuff in Rust. And I think
they need to know
TypeScript is
I don't think they need to mind, but I think the really exciting thing about Restate from like an operator perspective is that it's like a single binary. It's really easy to get running. Like you can run it on your machine. That's not like the dev server. When you type restate-server and press enter, you're running like the actual thing, and it runs exactly the same way on your laptop as it would when it's running on cloud or when it's running like on an AWS box or whatever. And I think that's cool. And Rust gives us a lot of nice properties there about it being very low dependency. And we don't ever want to have to rely on like an external like etcd or something like that. Partly because several of us at Restate have had really negative experiences running complex distributed systems that have like 10 components and rely on like other distributed systems as well and so on. So we want it to be so easy to operate, and we also want it to be really, really, really fast. Like we want complex workflows to have single-digit millisecond overhead. From all of the writing things down. And to do that, you need to build a new kind of streaming storage system, and making that distributed and fault tolerant and still really performant. It's not very easy. And fortunately, I have some smart people working on that. And they are using Rust. And thank goodness for that, because I think it's a big help on performance for sure. And I can't write C++ to save my life, so I don't know what else we'd be doing.
Yeah, Rust is a great language for it, especially with the SPDK and IOU ring integrations. Like writing to Linux disks has just never been faster. There's a lot of really exciting work going in that space. No, I'll call it out because you didn't. But I'm going to say 9 out of 10 times problems with distributed systems is etcd. Like it's not fit for purpose. We should not be running it. I don't know why we're in this situation with Kubernetes and etcd.
Even better is when you have your DNS backed by etcd. Then you're really winning. But yeah, I mean, God, it's such a nightmare to run, and I'm so glad that we don't rely on anything like that. Zookeeper is worse. I think it's fair to say. At least Kafka's finally got off of that one.
Yeah, I do like that Kafka went and started using Kafka for that, rather than that's why I stopped using Kafka, because of the Zookeeper stuff. I had too many problems. I started looking at alternatives. Red Panda is a great one, which doesn't require Zookeeper.
We've taken a lot of inspiration from them. They're also obsessive about this zero dependency, simple, single binary, this kind of stuff. This is really, really awesome.
Except they went C++ and you went Rust. So.
Yeah, exactly.
All right. Russell's in the chat saying, so this is the async await of event-driven programming.
Absolutely. I often use this expression distributed async await, but it doesn't mean something to everyone. And I think this is something we struggle with in Restate, because depending on what language you come from, I should probably be using different words. And that the SDK is also, of course, different depending on the languages. But we're not, like, the thing we're really passionate about is the runtime and like the thing that makes this performant and successful. And we want the SDK to be whatever makes sense to our users. But it hurts us in communication, because async await turns off anyone who doesn't like async await, which is like, I don't know, half of engineers maybe.
All right. So I am going to get my screen ready for us to start taking a look at the docs and show people where they can get started with this as well. So thank you, Russell, for jumping in the chat. And then someone confirmed that. I don't know if Ahmed is maybe on the Restate team for confirming that.
Yes, he's our principal engineer working on the runtime. So if we have any really complex questions about the distributed architecture, maybe he could reply in the comments.
And do we have anyone here that's going to tell us how to work the Rust SDK? Because now that's the only thing I want to do.
Definitely not me, because I've never tried it so far. I have no idea who's watching.
No 11th hour changes to it. Let's try.
We'll do a second one. Don't worry.
All right. I am going to throw up the screen share, and we can just talk about how people get started with that. I mean, is there anything I've missed that we haven't covered? Like, do you feel that we've given people a good overview of what Restate is and what it delivers?
Yeah, I hope so.
Righty. So here is the Restate.dev website. It is 1.0 with a cloud offering and seed funding. I mean, it feels to me that Restate is about 2 weeks old. I know it's not, because we've been chatting for a while now, but it's been, I mean, you did not waste time getting to that 1.0, I've got to say. Like, a lot of projects these days, especially in cloud native, I feel like they've been around for 10 years and they're still in 0.12.176. Like, clearly you set a mission and you're like, we want to deliver this. This is what we're going to deliver, and we got there. Maybe you could talk about that.
We're on a mission, and really 1.0 is about stability promises, and that's really scary and stressful thing as an early stage startup. It's like, are we sure that our feature surface now is the one that we want to like stand by for I don't know how long? But yeah, we have to be stable really to persuade people to rely on us for their like most critical use cases. We're not like a monitoring tool that if it goes down would be really annoying, but or if it changes the API would be annoying, but fundamentally it's fixable. We are asking permission to be one of the most critical components of infrastructure, and that's why stability is so important.
Okay, awesome. So if we scroll down, you're kind of already summarizing a few of the main use cases. We've got workflows as code, and we can see a nice example here. I'll quickly work out if I can see what that's doing. So you're creating a new Restate service, and there's a handler, and then maybe we can just give people a bit of context on what context.run means. I mean, this is how Restate handles side effects. Is that the right way to put it?
Exactly, yeah. So things that you want to happen ideally only once. And once they've happened, we'll save the result, and we would guarantee that on failure or anything like that, it won't need to happen again, and its result will just be filled in.
Nice. And there's also the Java example sitting here front and center, which is already hurting my eyes. But
avoid. Yeah.
I think that's an important. I think that was a really clever. I don't know who at Restate said let's get Java out early, but the enterprise world and the Java world have been doing BPNM and workflows and event-driven systems and actor-driven systems and all this for decades. Like, this is not new paradigms for them. So I think that's a really slick move to just support that world completely.
Also, all of my founders, they built Apache Flink, which is like a streaming system, which is all written in Java. So thank God Restate is not written in Java, because I personally really, really hate Java. But these guys really know how to write Java, and they really understand that world. So I think it was always a big priority for us.
I think Java is. I can't personally see it ever getting back into developer hands, like developers that are forward, future facing, front facing, whatever you want to say. It just feels like legacy to me. But then I am wearing a Go t-shirt. I am writing Rust day in, day out. I am playing with shiny new languages. I could sit here and talk about Ponylang for the next 6 weeks, and nobody would even know what the hell I'm talking about. But it's a super cool language, even if slightly academic. And I don't know if Java.
Java is where the work is getting done for most of the world, and I guess for us, like, the more traditional your software systems are, like, the more excited we are, because while I think we have a huge amount of value to people that are cloud native, many of those people have already learned how to solve these problems that I'm discussing. I think they can solve them easier with Restate. But there's another group of people that it's like they are actually struggling to get off of mainframes, or they are struggling to get off of monoliths, and for me, like, that's even more exciting because there's so much value to be unlocked there if we can help them do those things.
All right, awesome. I'm going to pick one more randomly just to see what code it gives us. I mentioned state machines, so let's pop that open. So this one actually has a state machine example implemented with a switch case. Not the worst way to do it.
So there's actually something coming out this week. I don't know if you've used XState.
Yeah, I love XState. I use it all the time.
Yeah. So we have made it possible to turn any XState state machine into a Restate service, and it can run serverless. So you can have these like virtual state machines running in the cloud invisibly and move between these different states, and we will just store all the results. But the critical primitive here that you can see is context.set. So Restate has a type of service called a virtual object, and those objects have a key, and therefore, in a sense, they have like unlimited number of objects. Each one kind of has its own state, and that's durable. That persists beyond the handler. I mean, it can exist forever. So you could use it where you would use Redis, You could even use it where you would use Dynamo or like any other database, just to key value store essentially. And what's cool is you have like guaranteed lock over that state while your handler is running. And that makes a lot of things a lot easier, but because it's specifically on that key, you're not like locking a whole table or anything like that. And that makes this quite simple to reason about when you're dealing with like distributed state. So for a state machine, it just means you can just like write the various fields down. But if you want to do things really fancy, we now have this XState integration. And there what we do is we just basically save the whole state of the XState state machine to a JSON blob, and then we rehydrate it whenever the next event comes in.
That's awesome. The reason I like XState is because the company behind it has the ability to actually visualize the state machines in a really nice way, which is great for documentation.
Absolutely. And I think we would also like to have more in this regard, because Restate has a lot of information about what your applications are doing. We understand these steps, the run steps, and also the calls between services. It's actually quite hard to create a call graph between all of your services. You can kind of get it out of Istio or Envoy or whatever. But like we have all of this information, also what you're storing and reading from the key value store. So we think we could do a really cool visualization.
So you're going to provide a Monzo Death Star as a service for people to allow them to have their own image of their architecture.
Yeah, maybe the call graph, but also like for individual invocation, what happened, like what did it do, where did it fail? A little bit like step functions. This is what people love about step functions. They just hate everything else. So that's what true. I would like to have for sure.
All right. Before we start typing code, there's just one other thing that you said, which was interesting, right? And you said there's locking that happens on the key level. So does that mean being built in Rust, you're hooking into like, I'm assuming Axum or some of the other actor primitives there to give every key a message box with, like, if I say update this thing and then another request comes in that says update this thing, you're not dismissing the second one. It's getting queued and then executed after, right? Okay.
I think the right way to think about it is it's as if these RPCs are going through Kafka in both directions. But the critical difference, and really it wouldn't work very well with Kafka, is that Kafka would have partitions that have many keys, and a single stuck request or failing request or whatever would block the whole partition. And you might only have, 64 partitions or something. So in Restate, we don't have header line blocking like that. So you can only block the key, which would be the user ID or whatever. So a user can be in a bad state, but not a whole partition. And if you've ever managed Kafka, you would know that these block partitions are like bane of your life.
Yep, been there.
So yeah, so that's what makes it kind of possible for us to not have these like nasty side effects between different users. So yeah, it's a pattern I've actually seen, is that people have an RPC framework where all requests and responses go through a queue, and that's essentially the primitive of how it works, and it gives you this really nice linearizability over a particular user. Like for a particular key on a particular service, they will process every request in sequence, and that actually just makes life a lot easier. It doesn't, in my experience, have a significant performance impact. And we also have these shared handlers that get a read-only view of a snapshot of state, and they can run concurrently. And even if you're not doing things with state, this just gives you like a lock primitive, basically. It gives you like a little bit of a read-write lock primitive, where you can have some handlers that will always run only one at a time, and some handlers that can run concurrently. And this is just, generally, that's all you need, I find.
Awesome. All right, show off the nice diagrams, talk about Rust a little bit more, and then let's get into the docs.
All right.
So our plan today is really to give people a taste of how they get started with Restate, what that local developer experience looks like, how they write their first durable function, and then we'll try and later on a little bit, explore new things, especially try and get the concepts and the primitives in there so that people can just understand that lingo and then hopefully start to build something.
Sounds good.
And we said we'd start with TypeScript. I mean, is there a magic link for me to get the Rust SDK? Just asking. I'm not saying we do it.
Not in the docs, but maybe soon. I'll send you something.
Right. Okay. Now, from my end, and I should have done this in advance, is I will need to set up a couple of things because I am on Nixos and I can't just download binaries like an idiot.
Of course not.
Yeah.
It's a daily experience for you, I imagine.
No, I mean, well, within my own repository, like I use devenv, which gives you this wonderful little Nix file. And I use progen, which generates new services for me with everything I need. So it's just, I've got it all down. But I don't like to do too much in advance before these sessions. But then this isn't important for the audience. This is just me being annoying. So I'm going to enable TypeScript and JavaScript. We actually don't need anything else from Nix. And what I love now, why have I got so many spaces? Oh, there's my mono repository because I was working on it this morning. Closure. And then I hit return, and now I should have Node. Nice, but I won't have npm because I forgot to do npm. Now, normally I would use bun, but I'm not going to rock the boat that much today. So
it does actually work, by the way, for the record.
Yeah, I just find bun is such a pleasant tool.
Yeah, it's so much easier to just do bun run for everything. Yeah, I use it also for demos a lot.
But I want to. The docs are using npx, so I want to just stick with what the docs are doing.
Yeah. Keep it simple. Yeah.
So this gives us our first example, which is just going to create a greeter function, and we can just run these commands like so. Now, there are a whole bunch of examples and templates, right? And if people want to see what else is available, they come to this examples repository.
Yeah, exactly.
And the templates are here. So
yeah, so also you can get these templates from the Restate CLI. So I guess we'll download that a little bit later. But once you have that, you can just do Restate example, and it can give you like a starter TypeScript repo, or it can give you a starter Go, or really anything. And that's often a good way to get started.
Oh, nice. All right, let's see where we are. We've got stuff and things. I've got my code. And if I pull up this template here, let me, that's a silly way to do it. Let's just change the font size. 24 doesn't feel enough to do. Yeah, it's better. Do you want to just walk us through what's happening here? Then we'll run it and give people an idea of what's what it looks like.
Absolutely, yeah. Okay, so let's start at the bottom. So we are creating a new Restate endpoint. What we really mean by that is like essentially a process running on a port, but actually behind that there can be any number of services. This is a little bit like a sort of gRPC server, and all of Restate has these like RPC-style semantics. And we bind to that endpoint a service, which we create in line. So we mentioned before that there are virtual objects. There are also services which are unkeyed and don't have state. And then there are also workflows, which are kind of an interesting special case of virtual objects that can be very useful. So we create a new service, and we define it as having the name greeter, and we give it one handler. And that handler is greet, and the greet handler, a handler really is just any function that accepts a context, or for stateful handler, it might be an object context. And any input parameter can be a string, can be an object with fields, doesn't really matter. This is all going to be encoded by default with JSON, but this is also configurable. And then handlers can just return or throw. So it's quite a simple way of defining handlers. It's probably recognizable if you've come from like the TRPC world. And through TypeScript type magic, exactly like TRPC, you can have clients for other services, and the types kind of all work, which is really nice. And actually, in many ways, it's a better experience than almost any other language we have an SDK for, because TypeScript is so powerful for this, which is really cool. So yeah, that's it. And then at the end, we're listening on 9080, which is the port that we tend to use. And the way Restate works from an architecture perspective, I recognize I didn't say this before, Restate calls your services. So it's not quite like a queue in the sense that you create workers and like pull down messages and process them. You can actually run your pods like kind of fairly normally, including behind load balancers, and Restate will just call them over HTTP2. But you don't call your services directly. It needs to be called through the Restate binary, because Restate is doing this like magical stuff behind the scenes. And in fact, you can have a long-lived HTTP request to Restate, and it might make lots of short invocations to your underlying service. It might be making Lambda invocations. There might be thousands of such invocations, but to you, it just looks like a simple, HTTP request. So that's roughly how the protocol works. In this case, we're serving on 9080.
Nice. So I'm going to just copy this because there's one thing I think we'll say, right, is that Restate isn't particularly opinionated in how you structure your code. Like you said, you write your code your own way, right? So if I call this Scotland, I will need to obviously pull in Restate again. Is that you can just structure your code however you want. I'm exporting this function. I can then import Scotland, and then we can just layer on these bindings, right, to add as many services as we want. So
yeah, absolutely. Or you can indeed you can define the restate.service in the other file and import that, all that sort of thing. The only thing you need to be cautious of is when you are trying to just have a client for a service, you generally want to make sure you're only importing types and don't import the whole file, because otherwise at runtime you could be importing all of the handlers, which maybe doesn't matter. But if you have like a large monorepo, it will start to matter. So this is actually also quite similar to RPC, the way we've approached it.
All right. I'm just going to make this different so we can call these. Well, I don't know how to get a whiskey emoji. There we go. I had to Google it. That's unbelievable. The emoji picker wasn't
That's
working.
How I do it.
I wonder if I could just have said, whiskey emoji, please, Mr. AI.
Ah, whoa, okay. That's very cool. I don't have any AI assistants, so.
Yeah, Copilot is fantastic. It happened me to explore other ones, but because it's right in VS Code, I just it's
for sure.
Okay, so let's go back to the documentation, right? So we did this, and then all we need to do to run this new service is to do an npm run app dev. Now, app dev, I'm assuming, is just a script in our package. Yep.
Yeah, it's using ts-node.dev.
Okay, so npm run app dev. Now, is that enough? Are we working?
No, because we need to run restate. Otherwise, it would be quite a magical library to do all the things that I said without running anything else. But unfortunately, no. That's another thing.
Right. But I think this is cool for people to understand. With restate, you need a restate server, and then your functions, your services, your workflows, those are all deployed by you wherever you want. I use Cloudflare Workers, but yeah. Okay.
Exactly, yeah. And yeah, so in that sense, we can sometimes look a bit like an API gateway, or a little bit like a service mesh even. So, but sometimes people really don't like these kind of concepts. So I never know whether to mention them. But something like a durable API gateway or a durable service mesh might be a good way to think about restate.
Right. So now it's telling us you need a server. Now this is where things are going to get interesting. Is it a statically compiled binary?
It is. Is that gonna? It should be.
No, that's fine. Yes. Static is okay.
It should be Musel, yeah. This is a real test to see if this works on a Nix machine.
Hey.
Oh my goodness. Yeah, that's great. Yeah. Okay, cool.
Static binaries are fine. The minute there's any dynamic linking, I mean, I just say goodbye and we say, we'll meet you in the pub next week or something. But
yeah.
Okay, so we have a restate server running on 000 binding, port 8080. We have our JavaScript Express-like server running here on 9080. So now we need to do a little bit of glue magic.
Exactly. Yeah.
And as it's telling us here, I need to do this via npx, but we have to register our deployment with the restate server.
Exactly, yeah. And let me maybe expand on what deployment means. And this is a very overloaded term in distributed systems, I suppose. For us, a deployment is referring to like that physical location at which services run, but many services might run there. So your deployment might be a Lambda ARN or a URL to a Cloudflare worker or a localhost port, but it's completely unrelated to what services might exist. So you have a restate cloud set up, it looks like, and you currently configured. So you need to do restate config use env local, and then it will start talking to your local restate service instead of your cloud service. We're getting ahead of ourselves.
Nice. I was just going to blow away that whole directory, but that's nicer.
Cool.
All right, so it's telling us it wants to create a deployment. There are two services that want to be added, Greeter and Scotland. It gives us the inputs and output values for these, and we can choose to accept or deny. So we now have two services deployed to a Restate server being delivered via whatever means we want. Easy, job done. All right, we're just getting to the easy stuff, right?
Yeah, absolutely.
All right, so I'm surprised I have curl. That's good. Okay, so we could do curl to the Restate server, and this is just a gRPC, right? We're just doing greeter greet.
Yeah. Except no proto. I should have already said this. When we first started Restate, there was a lot of proto stuff, and we just quickly realized that the developer experience is really bad in most languages. So it's everything's just JSON essentially. We don't actually, the Restate server does not inspect at all what the bodies are. So it just gets passed to the SDKs. But the SDKs by default will use JSON input output.
Yes. I do like that it's HTTP based and not Proto. It does simplify things.
Yeah, it was such a nightmare.
Pavel's in the chat saying that binary is a statically 1.1 binary that's apparently hot off the presses.
I think it's today or yesterday evening that it came out. Yeah.
Sweet. I like Bleeding Edge. So we got our high, but now, of course, I'm going to test our Scotland one. So let's pop back over. What did I call it?
I think it's Scotland/Greet. No? Oh, no. Scotland/Scotland.
Scotland. Way nice. So, I mean, there's not a lot to that, but I think what's really powerful is just what we're getting there, that bedrock of just a system that we can now build. I don't want to say anything, but I'm going to say almost anything on, right?
Question from Russell in chat. If you stop the process, do you need to be registered? No. So Restate is like stateful. Of course, I guess that's how it works. So not only do you not need to re-register services, but if you stop the process halfway through an invocation and resume Restate, the invocation will complete. So you should be able to, halfway through a request, kill Restate service, the underlying service, the whole machine, the whole data center, and start everything back up again, and it should finish. Now, obviously, if you had an HTTP request open, we're not magical. We can't currently keep the TCP connection open. But when we have multiple Restate instances as part of our distributed architecture, you would be able to kill any of them except for the one you're connected to. But the thing will always finish.
Can we demo that in a visual way? I've got an idea, right?
Yes.
We can use it. We can use a Restate CLI to actually, and I can't remember the command, so please help me out here. How do I list the invocations?
It would be inv-ls. And there should be a way to watch, or you can just do watch-n1. There we go. Okay, that was easy.
I like it when, I always quote myself, and I feel so cringy when I do it, right? But the best developer experience is where I can be successful with intuition rather than informed decisions. And that was intuition. So props. So we can call Scotland again, and it's too fast for the invocation to even show that there, right? So let's add a new, in fact, let's modify Scotland, because one of the things we can do is not respond right away. So we could do, and again, I'm going to mess this up, a sleep. And this is measured in milliseconds. So what is what is 1 minute in milliseconds?
60,000.
50,000?
60,000.
Yeah. I was about to look really stupid there. So that's a bit high. Let's go with 2 seconds first before I go showing what I'm trying to show. So if we do this, I'd have to redeploy my service.
No, you maybe just needed the npm dev to rerun. Should have worked.
Maybe that's not running on a. What is on a watch?
Maybe it's not respawning correctly. Yeah. Okay. But I seem to think it had been modified. Should we go back? Oh, await. JavaScript. You've been right into go.
Yeah. So now we have our 2 second delay. So let's bump this up, and let's say 30 seconds is how long it's going to take us to stop the Restate server, bring it back. Now, we're not going to get a response to the CLI, but we should see the invocations, right? So
we should see the invocations, exactly, yeah.
all right, so 30 seconds. No. Yeah.
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 And why don't we start with not stopping restate? Why don't we just stop the service? Because it can be cool to watch the HTTP actually finish if you stop the service.
Ah, okay.
You close that.
So we have our invocation here, which is telling
Yeah.
us that things are okay. We can restart that service.
So you might want to do, once we have that ID, we can also do inv describe, and you'll get a little bit more information about it. Anyway, it's about to run, so.
Yeah, that
And then it will continue the sleep. But what's interesting here, it's not going to continue the sleep from the start, because that would be really annoying, because then if you keep failing, it's just going to do the sleep like with the original wake up time. So you actually shouldn't affect how the curl appears at all, the fact that you stop the service.
And in fact, we could demonstrate that by just printing out. I don't know if I'm teaching people how to like suck eggs, right? But
so if you should use context.console.log, I think. Yes.
And can we just do
so logging is an interesting one, because how does restate work? It actually does run the function from the start. It just fills in all the sort of meaningful side effects from what happened last time. And that means that if you just do a console.log, it will usually log again on resumption. If you use context.console.log, it will usually not, but it still can in some situations. Let's see.
Okay. So here we have.
You can see that's the first invoke. Yeah.
We can shut that down.
Yeah.
We can just, do something for 10 seconds. I'm just trying to make sure that this comes back just in time for that 30 seconds.
Yeah, exactly. Yeah.
All right, it's been long enough, so we can restart that. It's going to do the magic.
Okay, it's getting resumed. It didn't do the original log again, which is cool.
Oh yeah, I didn't even think about that bit, of course.
Yeah.
There we go.
37, yeah, exactly.
17 to 37. Is that not magical?
Yeah. That is the essence of it. This is the essence.
Look at that function. Really. It's ridiculous.
Yeah.
It's just coding has never been this easy. This is just joy in my face. This is what pure joy looks like.
Absolutely. And what's even cooler, right, is, so let's say that we deployed this on a Lambda. It wouldn't sleep at all. Like the process wouldn't wait for a millisecond. It would just immediately stop. And then 30 seconds later, it's a completely new Lambda invocation. What's cool about that is the way that Lambda is built is like each invocation is really, really cheap, and you just pay for like milliseconds. So you're getting something a lot closer to the Cloudflare worker primitive, where you pay for CPU time and you don't pay for IO time, which in practice on Lambda is impossible. But this is something we want to help people get to on Lambda, because Lambda is such a great platform.
So, I don't want to get into the depths of it, right? But I have always been curious. How are you hydrating this function to a point that it can just jump through to that next stage?
So every line is running. We're not doing any magic. We're not saving stacks or stuff like that, because that will never work when you change your code. The whole thing will just segfault. We still run every line of code, but we are sort of injecting the values. So when you do a context.run, we're going to be like, we did that before, so we'll just immediately return the value that we saved. When you do a sleep, we are figuring out how much time we actually need to wait for. When you do context.console.log, we check, are we replaying? By which I mean we're zipping through the function to the point that we left off. If we're replaying, we just don't emit any logs. But if we're not replaying, then we will. So is that
just like memoization based on our invocation key and some representation of this line of code?
That's exactly right. It's memoization of a journal. A journal is just a list of operations that you completed, but the actual number is very small. It's basically runs, sleeps, calls to other services, get and set. So writing an SDK is basically implementing a state machine over these operations. But the fundamental thing is you are writing this log. The log must be stored by restate successfully before you continue. And then our job is to give you back that log as quickly as possible on resumption, and therefore have a very low overhead. And so there's these logs per invocation, but also restate itself is a massive distributed log. And all of those little logs kind of filter into that and create one big log for your entire system. And it's very pretty, really. But that's how it works.
Okay. So we obviously don't have a plan for what we're going to demo, but we started, well, I say we, right? I've dragged us down this Scottish theme here. So now I'm thinking, can we write, and I don't know if this is interesting or too trivial, but say a workflow where we can use signals to say, drink a whiskey, drink a whiskey, drink a whiskey till it falls over after so many whiskeys. Like show a stateful workflow where we're sending events or messages that then change the output of the workflow.
Okay. Yeah, sounds good.
Does that show enough, or should we just go to one of the demos, the examples?
I mean, I was also wondering, do you have any, because you're running Restate in production, right? Do you have anything that you actually want to build for Rawkode? I mean, is there any, maybe we could be helpful in some way?
I do. I'm now just worried that I'm going to have to give people context, and we have
okay. Yeah,
30 minutes. I mean, okay, what we can do, right, is I'll show you the one that we've deployed, and I can tell you what I'm doing next. So, Projects, Academy, and RPC. So I started off going down, this is going to turn into like a you help me session, but whatever.
That's great, I know.
So like I said earlier, I implemented the user activation story. Now, the way I thought I was going to do this, and it goes against everything that I wanted to do, so I have changed tack a little bit, is I thought I'll just have an RPC system, which is publicly browsable, rpc.rawkode.academy, and you just get this web page here. It's an Astro website that is deployed to Cloudflare functions and pages, where I have pages configured for the restate entry point, which is just me making sure I can pass on requests via the different handlers to restate. Nothing magic there. It's not that important. But we do have this user registered event which can come in, and I'm using some trigger.dev and some restate here, so I'll try not to go on it too much, right? But we have a webhook from Workos, which is closed source thing, which I didn't think I would use until I seen that you get your first million monthly active users for free, and I was like, I'm never going to have more than 1 million, so that's just free. And I like free stuff. Where we have a restate client, and then depending on the event that we get, we are using our handlers from restate to trigger the user created, which creates our workflow, and then when we receive the email verification, we then trigger that. That's it. These are just functions where we get the client, we submit. I'm assuming people are easy to follow along with this. There's nothing weird or interesting happening here.
It's worth noting that these are clients for users outside of Restate. So there's a kind of a concept of like you're either in a Restate service or you're just other code. And of course, Restate services have to interact with the rest of the world. So what we do in TypeScript is we have these typed clients that give you basically the same API for calling services, except they actually go through the Restate ingress, which is running on 8080. And as such, they don't have exactly the same magical properties of like RPCs can't fail, for example. They can still fail, but they have support idempotency keys. So you can generally come up with a very simple RPC retry type mechanism. And then, of course, once your request gets into restate land, then it has all these properties.
Yeah. I guess worth pointing out is we are using the idempotency key here. So whenever Workos sends us a webhook that is individually keyed, and we will never send an email twice because we have this idempotency key in theory and hopefully in practice. Not happened yet, so that's good. Now, the next thing is the actual, the registered handler itself. Now, what's cool here, but I don't want to show the code yet because just to make sure people understand what's happening. Anyone can register in the Rawkode Academy. But what we don't want to do is send an email to someone who hasn't verified that it is their email. That's going to lead to spam or abuse. So, I mean, if we could just spend 30 seconds on how would you do this without restate? Like if you had to build this yourself, what would you be doing?
So I guess you can write into the database once they've been verified. That's easy, at least. So once they click the verification link, that's going to write a key in a database. Okay, no problem. The annoying thing is that I have to like scan the database to like nightly or whatever to see who's been verified in the last day or whatever and send messages. Or I can alternatively do some kind of event emitter thing. So when I write that key, I also emit an event with PubSub or something. And then I have a PubSub consumer running in a process somewhere. and that is the thing that actually sends emails in response to those events. So probably need to use a database and a queue and have a few different handlers like interrelated with each other.
Yeah, and there's challenges with that approach, right? And I'm hoping this is familiar to people. If you go with the batch approach, which is like when someone does verify their email address, we're going to write something into a table called verified with a timestamp. Every night you look for people verified that day and you start sending emails. Not a great approach. Who wants a verification? Who wants their email 24 hours later, right? It's not cool.
Yeah.
The real-time approach, you've got two ways of doing it. One, you can do CDC on the database. That requires more configuration, setting up pub subs, all that stuff. Or you write to Kafka, but then you've got the dual write problem, which is well covered in event-driven systems. And that can you publish it to Kafka without confirming that it's been activated in the database, because you can't do a transaction across two different systems. So it's such a simple problem on the surface, but actually doing it in a resilient way requires effort and due care. And here's the function. So there is a lot going on here because I've been playing with context set and phases and trying to, just explore restate in a bit more detail. But the only line of code that is important here is that when our user is registered, we use this durable promise. And I'm just waiting for an event on this user ID that says that that user has verified their email. That's it. That's that entire system that we just described. And then everything after that is just me sending an email, which is handled via context.run, so that it is hopefully only ever going to run once. Well, do you say guaranteed to only ever run once? I'm not sure.
So this is impossible because you could get to the last line of the function and the process could die, and we just don't have any information to know whether it ran or not. What we say is that after there's been a successful completion that's committed to restate and we move on to the next step, it will never run again. And this basically just makes idempotency a lot easier to reason about. In this case, I think it is technically possible that you could send the email twice. And I think if resend accepts an idempotency key, you could just inject one in there and that would solve that problem.
Yeah, I mean, the challenge is I'm running this in a Cloudflare workers, which don't come with guarantees that my worker won't be killed or whatever. So yeah, there's, and that could be a
but I think it should still be
customer.
possible. If you do like context.ran.uuid, then you get a UUID and that will stay the same. And then you can pass that on to resend. But I mean, yeah, also resend probably can't guarantee it without some kind of inbound idempotency key.
No.
Technically, it's just not possible without a stable identifier to prevent emails from being sent twice.
But it's as close to guaranteed as we're going to get. I'll say that. I'm quite happy to go in the room and if you want, if you're not
absolutely,
happy with that. But I just loved, again, this is how I guarantee that we don't send an email until our user's verified. There's no pub sub, there's no CDC, there's no writing to external data sources. It's just a promise waiting for an event. And I think that is just...
but it is the pub sub approach that we discussed. I mean, Restate is essentially splitting your handler into a before event received step, which would be one handler otherwise, an event receiver, and then what to do when the event is received. And it's got the KV in there, like the KV read and write. It's got the event receive and send, but it's just all in the same handler. And I guess that's the magic, really. But it's still like the best in class approach, I guess.
Yeah.
There's no hacks. We're still just doing pub sub. We haven't invented like a new distributed systems approach. We just kind of given you a different API, I guess, if that makes sense.
Yeah, that makes sense to me. So the bit that I hadn't showed here is we just added a new, I don't know if you call it functions, endpoints, whatever, to this, which just resolves that promise for us. And then I'm triggering that by just pulling out the client and calling that as a function. I mean,
So this named promise thing is like a really handy feature of the workflow primitive in particular. And that's kind of what we created workflows for, is to have this concept. But in general in Restate, we have these things called awakables. And they're basically like promises that you can share between services, and they can be resolved with any value or rejected with an error. So you could pass around awakable IDs and basically have like really complicated async processes between services, and awakables can be also resolved at the ingress. So you can have like an inbound webhook that resolves an awakable. But the special case, like the simplest special case of awakables, is in this workflow setup, where you're mostly trying to communicate between handlers of the same workflow. And for most purposes, that is really, really easy and kind of simple. And I guess our approach is we want to make it possible to build anything. Like you can actually build a distributed queue, for example, on top of Restate using awakables. We want to make it possible to do anything, but we want to make it easy to just kind of do a workflow that does simple things and not have to worry about like creating complicated processes, essentially.
Awesome. All right, so that leads us on to the next step, is that I then decided this isn't good enough. Not Restate. Let me clarify. My deployment mechanism here is I'm essentially building this monolithic RPC deployment where if I break it, I'm actually breaking a whole bunch of different handlers. Now we get guarantees and resiliency by going through Restate. But everything else in my system is deployed as individual Cloudflare workers. And that's the approach that I started to take when I was looking at my technology service. So if we pop back up, this is where I'm worried about just oversharing on what's actually happening here.
Okay, no worries.
But any service that we have gets boiled down to a data model, a read model, and a write model. The write model is all handled via RPC. So just tell me if I'm glossing over anything too much here. We have a schema defined in Drizzle, and we're using the Drizzle Valleybot plugin. For anyone who's not aware of what that is, Valleybot is like Zod. It gives us TypeScript types that we can reuse in other parts of the system. So while this data model allows me to write to the database, I'm actually not handling the writes in this service for reasons I can get into if we want to go into it deeper. But just know we have a schema here, and then the read model is all delivered via GraphBase. GraphBase is the GraphQL front end kind of thing, where I can just say I have this type. This is the query I want to satisfy, and it does all the jobs. The resolver for this is using the Drizzle client to query the table and done. Now, the reason this is overly more complicated than I'm getting into is that in some cases, in fact, let's just show this off because this is where things get a little weird. Now, most people would have a shows service, which I do, which has all of my shows on my YouTube channel. I then have a people service, which has all of the people that have been guests. And the reason I separate these things is so that the schemas are small, migrations are non-existent, and I can replace the services. Like the cloud native microservice.
Basically, they're a little bit like virtual objects.
But then I needed to then say, well, people can be a host of a show. So I needed a new service for that. Now, what GraphBase does is it actually allows me to define fragments of these types, and it does the aggregation at the front. So what I'm saying here is that we have a person which is not resolvable because this is not the person's service, but we know that they have an ID, and that's how they're keyed.
So it's a foreign key, essentially.
Exactly. Yeah, we're doing distributed foreign keys across services. Then the show is a service which is also keyed with an ID. It's also not resolvable, although we don't mark it as not resolvable, because we have this new property that we want to add to it. And what we're saying is we want people to be able to query hosts, which resolves to a person using this resolver. And what that means is I get this very cool API, and I'll just log into GraphBase quickly because I don't have a GraphQL client available right now. See, this is the rabbit hole I was worried about going down.
No, it's okay. I think this is pretty cool. I think it's so interesting to look at like real world Restate usage.
Okay, so here's my single API where I can do a query and I can say, give me all my shows with the host and get me the forename. This is where it's not going to work, right? Don't do it to me.
Oh, there you go.
But we didn't get the show name, so here we are, right? We have Rawkode live, and we have a host with a forename. Oh yeah, it's just weird formatting. There we go.
That's good.
So that's actually querying the shows service, the people service, and then the aggregation service injecting all that thing.
So this is a distributed join, essentially. You're joining across two different distributed services, yeah.
Exactly. So
is this all hitting the same underlying database, or are they
no?
Okay.
Every service has its own libSQL TurtleDB So it's all
Okay, all right.
SQLite, which makes local development experience very nice.
Okay, got you.
Now this presents a problem, and this is why Restate is such a big part of my architecture now. Because if I want to create a new show, a new person, and a host of a show, that is actually a multi-step, right? I have to create the show, create the person, and then say that that person is then a host of a show. So I can't just insert values into a table anymore. And
Because it's two different services, I see. Yes, of course. Yeah.
So Restate becomes the orchestrator of these writes, so that when I do have a GraphQL endpoint, and this time it's a mutation, and say we say create show. I'm not going to actually do this because it's not going to work. Hosts, and that could be Rawkode is the idea, like whatever. This has to hit a resolver that can create the show, but then has to guarantee that the Rawkode exists and then create it with another server. So it gets quite complicated from a write perspective, but I'm okay taking on that burden because I get the read API that I want for the website, the platform, the apps, all of the automation.
Got you.
Very cool. So I know we're detouring it, fuck now. But let me go back to the technology.
I actually really understand the problem now. I was waiting for it to get to like the restate bit. I totally understand. This is a dual write. You've disaggregated. I mean, Armin's in the comments saying just do the whole thing in restate, mate. Problem solved. That is actually a cool idea. But you still have foreign. I mean, you still have foreign keys and restate. I mean, we still have this concept in restate. You still have like IDs and keys for virtual objects, and you would still have to read across two different services and write across two different services. The difference would be the writes sort of can't fail, I guess. They can't transiently fail. So if you just write call one and then call two to do the first write and then the second write, you don't have to have a lock or a transaction or anything like that because restate would guarantee they would run to the end. But you can still do this even if they're external systems, even if you have to talk to these services that aren't running in restate. It's just easier if they do run a restate, of course.
Well, we are quickly running out of time, and you've given me lots of food for thought there. I'm going to suggest that maybe there's a part 2 where we can actually dive into how we would go down a virtual object approach and build something out. But I'll finish my train of thought and just where I am with the technology service. Now, Restate isn't opinionated about where my services are deployed. The fact that I was putting them into a single RPC deployment was for convenience at the start, but now I'm like, actually, what I need is inside this technology service is a Restate directory, which has a single handler, which I deploy to Cloudflare workers and register with this server. And that way I can share my Drizzle value.schema, which allows me to do the input validation before doing the write to the Drizzle database. And that's going to be my model moving forward for every single write within the system. So every write is going through Restate. Nothing will go through GraphQL. It's all going to be RPC. But instead of having a single RPC service, I'm going to have many, many RPC services that Restate is the orchestrator of.
Yep. And do you think that these writes will still go Restate and then a non-Restate service and then Terso? Or would you be happy for them to be talking to the database directly from Restate? In which case things, I think, would be a lot easier.
I'm going to have Restate talk to the database, and we can. I mean, we've got 20 minutes.
Okay,
we could probably do this
talking
now.
about I think we could convert one of these
because the Drizzle client is right here,
virtual object,
right? So, so let's assume we did Restate, and I'll be bold now because I do have bun in this div inf, and I'm just going to delete that boring one.
Why don't you try there should be a bun template. Oh, have you used the bun template for Restate?
I haven't, no.
There should be, if you do Restate example, like with the CLI.
Oh, there is. Okay.
Yeah, you should try that.
Well, I don't have the CLI. Bun install.
Well, in NPX, no? Oh, sorry, you're in a different directory, so you have like totally different tools now, don't you?
Restate.dev, right?
Yeah, exactly, yeah.
That's it. Okay, so we can do bun, run, restate.
Example, done, I think.
Let's just pull it up. So.
No, I don't think it's used there because you don't have the CLI yet there. Maybe, I don't know where it would be used. Operate.
We can just run help.
Let's give it a try.
Because it's in my globals. So.
Okay.
Oh, no.
That looks right.
Oh.
There we go. Yes. Okay. So it should be example. Yeah, I think you can just run example and then it will ask you. If you just do example, it will ask you what you want to do. Yeah. TypeScript. Run hello world. Nice.
All right. I'm just going to extract this up. I'll blow that away. I don't mind. Don't know what temp.zip is.
You don't need the zip. You don't need the zip. Don't worry.
All right. Okay, so now we have a greeter service in Bun.
Yeah.
And I'll just make sure that works. So I should be able to do...
I don't know what the script is for Bun. It's just dev.
There
we go.
Dev. All right, okay.
Should unify those.
Bun install. Okay,
yeah, we just got it running on another port. Not that one, I think. That one, yeah.
Okay, nice. Good. So now we have a service. So now what we want to be able to do here is called create technology. I don't think that's really important, but I know I'm going to technologies create. And that's one step closer. This could literally be the first public use of the just released 1.1.
Yeah, I mean, yeah, it's true.
You sure you don't want to do this in Rust? No, I'm just...
No.
Okay, so we already have types here. So let's do import from drizzle. Drizzle schema. So now I wouldn't normally import them like this. I would Bun workspace it, but.
And are the drizzle like operations, like when you do get and set, are they sort of idempotent? Like how does drizzle do? I guess it's that transactional.
I mean, I could do
but
it.
But would it always be like create if null exists and this sort of thing, or update or insert, this sort of thing?
I think it's just doing an insert.
Okay.
But we don't need to get into the technicalities of it right now.
Okay.
So this gives us a TypeScript type. I'm wondering if I can just do.
Should be able to, yeah.
Type
maybe
of.
Import type.
There we go. And now we just have something where I could say technology dot no. Oh, we'll get to it in a minute. I'm sure we can work it out. So, see, as a value, let's not get ahead of myself, right? Let's just take something. Because what I can do now is I can use my technologies insert schema. We may have to look up the drizzle docs. There's a validate function.
You may be able to copy from whatever handler you currently have, right?
It's broken. I'm actually, because as you can tell, I'm on a branch where I've been rewriting this. So,
okay.
Yeah, here. Create insert schema. And then we can call parse passing in the schema.
Okay.
So, parse. I'm going to have to add drizzle to this. This is where I should have done it as a Bun workspace, but that's what I get for being half-assed. I mean, I don't really need this package.json, right? I just need these dependencies.
Yeah, I shouldn't need it. I don't think so. As long as
Just
there are
rather
no
than me
models.
duplicating all of this. Now, I know
Yeah,
there's cleaner, nicer ways to do this. But let's just take that out. And scripts is fine. Dependencies. And dev dependencies probably okay. Bun for air type
you
script.
don't need anything.
Okay. So package should be able to run bun install. It does the parent directory.
Mm-hmm.
This now means I can get pars, which is probably moaning because it's not used. That's okay. And here we can say pars like so. So now we know we have a valid technology. And I'll pull those docs back up.
And if we don't, I guess we would usually throw a terminal error, which is like telling restate this is like never going to succeed because the input is bad.
Yeah. The problem we have now is when I generate a type client for this service, I'm not going to get the fields that I actually need to be able to fill in. So I need to do, and I do need to solve that.
You need to solve the type of schema thing. Yeah.
Yeah, I need to work out that. So, but in theory, I should now be able to do, if we import knowledge table, start my imports for me. I was hoping that would move that here. And Rust, it would have done it for me. Anyway.
Yeah.
Oh, that didn't even work. Right. Now we can just say technologies. Well, this is a type. That's interesting. Okay. Let me pull up my graph base. I've forgotten how to drizzle now. It's too much pressure. Oh yeah, I need a drizzle client.
Yeah, that looks right. Okay.
Stop watching me. All right. Okay. Import, and schema.
That might be the type you were missing for. Oh no, that could be the insert schema.
That's the star. So. Which is going to have to go up one more directory. Yeah. No. Yeah. Yeah. Okay. Schema. So now this is actually db insert and technologies table. Okay. Now this is untyped. So, and it wanted an extra argument. Sorry, I'm just going to use the docs because I have no idea what I'm doing. Users values.
So you do the table first and then the, right, yeah, okay.
Done.
Nice. So if that's the last step, you don't even need to use a context.run because, I mean, it's the last step anyway. It's nothing afterwards would ever happen.
Yeah.
Well, that would work. That would kind of work. And then if you need to do like multiple of these calls, like you're calling technologies create and then you're calling something else .create.
So technologies is the easiest service and it doesn't have any dependencies. It just needs to insert a service. But, you know, if we were doing a more complex example, like the show hosts, yes, we would have to first do a query to make sure the show exists, make a query to make sure the person exists, then do the insert, assuming they're not already inserted into the thing. So there is a lot more logic. This is the most primitive version of the write that we could possibly do. What I'm curious about is where I can get that type to work.
Could be,
no, that's the actual table. So there must be a way to infer. Oh, there is a infer function, right? So, but I'm doing that with the insert schema.
This is voodoo to me.
Yeah,
the problem with this TypeScript type stuff is that when it's not working, it's like impossible to figure out why, and when it works, it's like so magic.
Yeah, I don't think it's important for the demo. Like the fact that I have this function which I can now deploy and register with, I think is important. I would love to be able to run it. I don't think it's going to work right now, and it's moaning about my libscale client, which I've not seen before. I'm not sure. Is that just because of this TS config?
Yeah, maybe you haven't imported it. Like,
Well, I have I moved everything to the root, right? So
and you definitely have it at the root.
So we're using this TS config. So I might be able to just nuke your restate one.
Oh yeah, you probably don't need that.
Restart.
Oh yeah, that fixed it. I think that fixed it.
Yeah.
Yeah, nice.
And I'm curious if that fixes. No, I can get to that type, but I can't. I'm not quite getting the exact type information that I expect here, but I think that's possibly because of this any type. Like if I break everything, this definitely fails.
Okay, yeah.
So yeah, there's something that I'm going to have to work out. I'm not going to be able to do it in 9 minutes on this session.
That's fine. That's totally fine.
I think that's pretty cool. And it's something that I need to get working today anyway. This was after this session. This is what I was going to be working on for the rest of the day. And I feel,
I guess the point here, right, is that like you haven't really written, in this case, the service in any different way. And the main benefit we're getting from Restate here is just for the communication between services, that becomes like exactly once and guaranteed, essentially. And if you can just make that db.insert step idempotent, I think that's important as well. If you can do that, then the whole thing that's basically the root of the distributed systems problem here. As long as the database write is idempotent, everything else should work with Restate.
Yeah, I mean, I can start a transaction, and then it becomes an idempotent. At least it's either going to success or fail. It's going to be atomic, and then that.
Yeah, atomic is easy with databases, but the critical thing is that it's like an update if exists. It's like insert or update is that one. I'm not actually a SQL expert, but I think that's the critical thing. It needs to not fail.
But I want this to fail
exists.
If the row exists. I want it to fail.
Oh, you do? Okay, but what if, let's say, it gets past the DB right, but then Terso fails or whatever, and then it wrote to the database, but it never returned 200. Then Restate will retry, right? Then we'll write it again, and then it will fail permanently. So, yeah, why would it need to fail if the row's already there? Isn't that 200 okay? Like, we're idempotent and we're okay.
Well, yeah, I suppose we can do an insert on update. Like, that would...
Yeah.
That would work.
Generally, I would say that's better.
Drizzle does support that anyway on conflicting do update, and then we just specify.
Great. Okay, great. So that's really all you need for this to be like a well-behaved Restate service. So the idea is that we are kind of saying here that failures are all transient failures and should be retried. The other type of non-transient failure that we shouldn't retry is the one where it is valid as false. In that scenario, I think we should throw a terminal error, and then just say, look, the request parameters are wrong.
Sweet. All right, I am going to be sat here for the next 3 hours at least working on tidying this up, because I'm now in a position where I was like I could put this in a Restate folder, but I mean, there's nothing. Yeah, this has got its own.
Now I'm wondering what other kind of services you need really than these kinds of services, because I mean, our hope is that we make every handler a bit better. Some handlers we make like 1,000,000 times better, but that every handler is like enough improved that it's kind of worth using.
Yeah, I'm very excited by this now. This is unlocked a lot for my setup. So I will definitely be doing some videos once I get this all working on how this all hooks together. But my main objective was data model, read model, write model. Between graph-based, Restate, and Drizzle, I have those 3 components. And I am very excited. Once I deal with the TypeScript thing here. Once I deal with that. And it's a simple thing. I'm going to go after this session. I'm going to pop us back to big face mode. Once I go through the Drizzle docs, I'm sure there's a page on getting that type and using it as a TypeScript type, and that's the final straw. So
exactly, yeah. I mean, you could actually have something, by the way, that sort of there's like a concept of higher order services. So you could actually have a thing that just takes a table and turns it into a Restate service that does the CRUD that you've just shown. So it does validation, returning a terminal error if it doesn't validate, and then does the update the insert or update. And you could have this that just converts any table into any Restate service, and not even have to write this like boilerplate each time. That could be kind of cool.
Yeah. I don't fully understand that, but
the point being is like the service that you've just written, it would look exactly the same if the table was different, right? It's just accept an input, check that the input matches the schema for this table that's previously defined, and then do the update. So there's no reason to write it for each one. You can just have a single implementation of like for a function that turns a table into a restate service, and then you can just bind all of those services for each table. And you only have to write that handler once.
Oh yeah, I mean, it could be a generic handler that takes a type.
Exactly, yeah.
Yeah, okay. Oh wow, that's pretty slick.
Yeah, it should work.
I mean, for the simple use cases where it's
if it's just CRUD, I mean, if you're doing some kind of other complex stuff, then yeah, you would still write the handler. But yeah, there's no point writing these CRUD handlers over and over again. You can just you're sort of writing like you're kind of converting a database table into a restate service. So you're handling all of the types of failure, like schema being invalid, or the write failing, and those become like restate services, those errors as RPC errors. And then once it's an RPC handler, you have all of restate's properties, like the RPC will happen once and will always complete and things like that. And they'll go through invocations. So this is a really nice thing. And something we would really like in the future is maybe even restate can even do SQL operations for you. So you wouldn't even need to write such a wrapper, but you can sort of do context.sql and we would manage the transaction and guarantee that it only happens once and this kind of magic.
That would be nice. Yeah.
Watch this space, but we would love to do that.
All right. I have taken up enough of your time for the Rawkode Academy self-help program. So
well, let's do a part 2 because this is actually really interesting.
Yeah, I'll get a few steps forward. So we get to that point where I think it's more interesting for the viewer to see a more complete system rather than what is right now a very early prototype proof of concept. But I like that generic handler idea. I can share that in my Bun workspace and the simple things can just pull that through and that's going to be amazing. And then I can get on to the more advanced use cases where we have real workflows with real challenges. And then we can look back and say, okay, here's where we are. What's the next steps? Yeah. Well, I know it's going to be worth it.
Absolutely. Yeah.
All right. Something I like to finish on is just to talk about what's next. Now, Restate is already a 1.0 release. You've got that seed funding. You've mentioned context.sql, which doesn't exist but could exist. Maybe you could share a bit of light on what's on the roadmap. What are you working on as a company and a team?
Yeah, so I would say 85% of the resources right now at Restate are working on the distributed runtime. So like, for context, we have come from the world of like building distributed systems and we have designed Restate from the ground up to be distributed. But right now, we've been running a single binary today, right? And that binary is single process. And a lot of the things that we're talking about are way easier in a single process. We haven't taken those easy routes, but we need to prove that now. We are distributing Restate. We're making it work in high availability setups, so like active, passive, but also like fully distributed sharded setups, like 10, 20, 50 nodes. And yeah, the design always accounted for that at the start, but to actually build like a distributed system with virtual consensus from scratch in Rust is obviously a huge amount of work. And I would say we are now in the last stages of that, but it's kind of taking up all energy. And this is really exciting because we want it to be possible that you can kill half of the Restate instances or lose a DC or whatever and have milliseconds of failover time or even no failover time. That's really important as part of our mission. So yeah, that's what I'm excited about. I'm really, really hopeful that we'll have something there like very soon.
Nice. Awesome. Any final words before we depart for today?
No, I think we covered everything. I've had a really awesome time. So thanks very much. It's been brilliant.
Yeah, really appreciate you taking the time to, share your story, the Restate story, and even help me debugging and planning some future Academy features. So again, thank you so much for your time. We'll definitely reach out and get a part 2 in the future. And I'm excited to see what you and the team at Restate do.
Awesome. Well, thanks very much. I'll see you next time.
Yeah, for everyone watching, thank you very much. Feel free to say something in the comments as we bid you adieu. Have a great day and the rest of the week. Bye.